All right, let's review quadratics again. So you've got standard form. That's the ax squared plus bx plus c. And there are two other forms that are generally considered more useful. But standard form is really common. And if you've got a parabola, it can help you find the axis of symmetry relatively easily. The x value of that, do you remember what combination it is? I hope you remember. It's the beginning of the quadratic formula. X equals negative b all over 2a, right? Negative b over 2a gives you the x value of the axis of symmetry, and if you plug that in, you can get the y value of the vertex. There's an easier way, though, to get the vertex, and that would be using this form that we've been talking about a lot in the last couple weeks. Okay. Do you know what form that's called? I hope so. It's vertex form. Because you just look at it and it gives you the vertex. Okay. That's the x value of the vertex. That's the y value of the vertex. Voila, we're finished. Vertical stretch factor. You're very comfortable with that form now. The third form is this one. A times x minus p times x minus q. Now I'm going to claim that you've used this a lot in things like, say I let the y value be 0. Where does that happen on a graph? Y value 0? Oh, the x-axis. Okay, if I let the y value be 0 and I have something like this, what does x equal? 3 and 5, right? 3, 5. Oh, that's the x-intercepts of my parabola. Make sense? So this is called intercept form. And it's worth noting that if you started converting from one form to another form, you would soon realize that these a values, they're all the same value. So if it's 2 for this one, then it's 2 for this one and 2 for this one, right? If you square your x and multiply this out with FOIL, the coefficient of x squared is a, just like this. Same here. Okay? So this a value transfers all the way through. All right. Let's do a couple of examples like you'll have to do with your homework problems. I'm just going to use movie magic to give you a little time to fill in these bits in your notes. All right. Here's our example. So say I want to convert this quadratic function into vertex form, which looks like that. I have to figure out how a, b, and c become a, h, and k. Well, we already talked about finding a. That's the easiest thing there is. Because even in this form, this a and this a are the same. So I can just erase this a and put right in my negative 2. Okay? A is the same. Now, though, I have to find h and k. Well, I know that if I could find on the parabola the vertex using this, I would have my h and my k values, my x and my y of the coordinates of the vertex. So let's use the axis of symmetry to find the x value. So the axis of symmetry is found with negative b over 2a. Negative b is negative 12 over 2 times negative 2. So that means x equals 3. I'll put that in right there. So I have the coordinates of this vertex at 3 comma something. And then I'll take this and plug it back into my equation and find my y value. So y equals negative 2 times all right, now I have my y value. I'll put that in as 4. And there's my equation written in vertex form. Okay, this is a pretty simple conversion. It's still a little bit magical right? You're trusting me that this and this come out to be the same thing. There's no manipulation of this equation to get this one. The way to do that manipulation, to go from here to here without fancy math tricks, is through completing the square. And we're going to do that as method 2 so you understand what's really going on behind the scenes. Alright, so let's do a quick reminder of how to complete the square, because I know it's been a while. So say you have this kind of problem where we're just solving for x. So the first step is to move the constant term to the other side. So you have x squared plus 14x, leave space, equals 2. And then in completing the square, you can actually add squares, blank spaces. So you can fill something in here. I know that seems juvenile, bear with me. I think it causes you to make fewer mistakes if you do it this way, so humor me. Alright, we're going to take the b value, and we really want something factorable here, and something that's a perfect square, right? So x plus something is going to give us this. Take this number and divide it by 2. Every time, cut it in half. 7 squared is 49. I'm going to claim that if you FOIL this, and do it real quick, right? X times x, x squared. X plus 7 times x plus 7. 7x and 7x is 14x. 7 squared, 7 times 7, the last term is 49. Okay? Cut this in half and then square this number. It'll always come out right. This equals 51. And you could solve this by taking the square root, etc., etc., etc. Right? Okay, keep that in mind. Let's go over here. Alright, first step. Move the constant term out of the way. Some people just shove it over and don't pay attention to it until later. I like to move it to the other side because it just cleans up this right-hand side for me. It's easier for me to see. Y plus 14 equals negative 2x squared plus 12x. Alright, now I need to complete the square. I'm going to have to add something else here. But first, I don't want that a value inside of the parentheses. Remember, in your final vertex form, that a is out in the front. So I'm going to pull out the a, my vertical stretch. I've got x squared plus, oops, don't forget it was minus 2, so minus 6x. And I'm going to add something right there. But anything I add to one side, I have to add to the other side. So I still have my y plus 14 here, and I'm going to add negative 2 times whatever is going into that box, so that I add the same thing, keep it balanced. Okay, keep the negative 2. We're going to cut the b value in half and then square. So x, half of negative 6 is negative 3. Negative 3 squared is 9. If you factor this, you get that. Okay. And over here, because I put 9 there, I'm putting 9 into this box on the left-hand side. Alright, so I've got negative 18 plus y plus 14. That's just negative 4, right? Okay. Move it over. Y equals negative 2 times x minus 3 squared plus 4. That's vertex 1. Alright, so sometimes the function you're given doesn't come with an equation in some other form. It comes instead with a graph. So let's really quickly, because this one's really easy, you're going to like it, convert a graph into an equation of quadratic. So the form we like the most right now is the transformation form, the vertex form. So you can tell how far it's been shifted over, up, down, stretch, really easy to analyze. So let's try to put it in that form. Let's see, we've got y equals a times x minus something squared plus, wait a minute. If I'm given the vertex here, and in fairness, I would tell you that this is the vertex, not just a random point on a badly drawn sketch. If you're given the vertex of 6, -2, then hey, you can plug it right in. So this is x minus 6, quantity squared, minus 2. Yay, I've got my oh, I don't have my equation. I need an a value, right? But conveniently, I've got this other lovely point. And if I plug that in, I can find the a value that makes the equation true for this point, and that must be true for all the rest of them. So let's plug this in. We don't know a, we'll leave that. -14 equals a times, okay, right in here, sometimes people mess this up and start doing the subtraction before they do this multiplication. Make sure this number becomes the coefficient of your a. Just a helpful hint there. All right. All right, so a is -3. That means that for a parabola to have a vertex at 6, -2, and be stretched correctly to go through 8, -14, the stretch factor must be -3.